one base, because there's only one of those shapes, and all these triangles. Now, we have kind of a problem here. With some of these triangles, depending on what we have, if our base has equal side lengths, like this one, all these triangles on the outside are congruent. They're all the same, so it makes it really easy. But if I even just have one side that's longer than the others, that side triangle that goes up to the vertex will be different. So we have two categories today. Hi, guys. One category is when we have irregular pyramids, which we're going to start with. So irregular pyramid. Okay, and an irregular pyramid means that the base shape is irregular. Does anyone remember what's the difference between regular and irregular? Imran, dude, you don't get to just come in and sit wherever you want every day. Yeah, and that one is also not supposed to be sitting there. Also, there's another chair up there, I think, that you can sit at. There isn't? Okay. Got it. Okay, so irregular. What's the difference between regular and irregular? All right, if you don't remember, we got to flip all the way back to chapter 6. Oops, 6-1. There we go. Here we have regular and irregular. Our definition of irregular is just that it's not regular. But what is our definition of regular? Equal, good. Equilateral and equiangular. What does it mean to be equilateral? What does that word equilateral mean? Good, the sides are the same and the angles are the same. Equiangular, angles are the same. So sides are the same, angles are the same. So if it's irregular, are the sides going to be the same? Nope. So that's what we're working on today for this. Our first one is irregular, so it's where the base sides are not equal or not the same. So when we look at this first pyramid, what shape is our base? Good, it's a rectangle. So when we look at this rectangle, are all the sides of the rectangle equal? No, so is this regular or irregular? Irregular. So when it's irregular, it's kind of a lot of work because we have to break apart this shape in our brains and kind of unfold it. So we're going to start by thinking how this base, we're going to find the surface area, and we're going to find the areas of each of these shapes we see represented. So first, let's start with the base. And our base is a rectangle. So how am I going to find the area of this rectangle? Base times height. And what's our base and height of our rectangle? 6 and 10. So we're going to do 6 times 10 is 60. Easy peasy. Now we need to identify the different types of triangles we have coming up from that base. So on one side of the base, we have that 6 centimeters, and we have this triangle going up to that vertex based on that side, the 6 centimeters. I'm going to do that one green. This one, really color coding, is going to help much more than even the next problem. Do we see how this triangle is different than this front triangle? Yeah? No? Kind of conceptually, this one's skinnier, it's 6 centimeters, this one's a little bit wider. So when we do this side triangle, I'm thinking about that as my green here. How do I find the area of a triangle? Not just base times height for a triangle. 1/2 base times height. Good. So 1/2. What's my base of my green triangle? 6. And then what's the height of the green triangle? 9.4. Yep. So 1/2 base times height. I'm going to use my calculator for that. I'm going to find my calculator. I'm going to use my calculator. One-half times 6 times 9.4. And we get 28.2. So that's the area of that green triangle. Now there's one more triangle that has a different shape or a different dimension, and that's that triangle that has that base of 10, because those sides on the bottom weren't the same, so this one's going to be different. So I'm going to use blue for that one. And I'm just outlining these. If you want to shade them in, you could, but they kind of overlap, so it gets to be a little crazy. Okay, and I like to call that one, I call it the front triangle, because it's kind of on the front side. Okay, and we're going to use the same formula for a triangle, 1/2 base times height. So 1/2 times, what's our base of our front triangle, that blue one? (10) times our height. What? 8.5, yep. Okay, throw that in our calculator. 1/2 times 10 times 8.5. And we get 42.5. So we found all the different shapes that are creating this irregular pyramid. And now we have to figure out how we're going to put them together. So let's start with our base. How many bases do we have? Just one. So we are just going to have 160. Okay, now if I look at those green triangles, those side triangles, how many side triangles, how many green triangles are going to come from our base? 2. Why 2? Yeah, there's 2 sides. There's one coming off of this 6 centimeters, but there's also one coming off this 6 centimeters. So we're going to do 28.2 twice. We have our side and our side. Kind of our left side and our right side. They're coming off each side there. Okay, then I have my front side, my front triangle. And how much is my front triangle? 42.5. Do I just have one of those triangles? I have 2, because there's one in the front and there's one in the back. So because our triangles were different, this one was a little bit more work. We had to think of each part, and then we're going to add these all together. Okay, and there should be 4 triangles because our base has how many sides? 4 sides, yep. So we have one base that has 4 sides with 4 triangles. Okay, so we're going to do 60 plus 28.2 plus 28.2 plus 42.5 plus 42.5. And we get a handy dandy 201.4. And this was surface area. So when we label our surface area as 201.4, how are we measuring it? Good. We write it as centimeters squared. How do we say that, though? Square centimeters, because we're literally talking about squares. So So we like to say square centimeters to remind the people we're talking to that we're literally going to glue, if we're going to glue this on. If I had 201 squares that are centimeter by centimeter, I could fit those on the outside of that. Alright, so that's kind of the big idea with irregular pyramids, which kind of makes it a pain in the butt. Not a big fan of irregular pyramids, but they exist in the real world, so we have to deal with them. Okay? However, most pyramids that we do work with end up being regular for this reason, that it's just easier to work with. So I'm going to draw a line across, and this is going to now be our regular pyramids. Alright, so for our regular pyramids, if an irregular pyramid means that the base sides are not equal, what would be a regular pyramid? Base sides are equal. And when we have equal sides on that base, what happens is that those triangles end up all being equal because they all have the same base. I'm going to show a picture here, or not a picture, I'm going to show a shape here, so if you panic, just breathe for a second. I'll take it off in a moment. Alright, so this one's a square pyramid. In this square, we have all the same sides. So when I open this up, even though my triangles kind of go around this way, all of these bases are connected to a side, and we know all the sides are the same. So all the bases of these triangles are the same, and all the heights are the same. So we have 4 triangles that are all congruent. They're all equal to each other. And because of that, we're able to use an easier formula. So for the regular pyramids, we have a formula that we can throw it into, make it easy for ourselves. So we're going to say SA, surface area equals and even if we look back, we had one base. So we're going to do a capital B for our area of the base plus and then we're going to have our side triangles. And remember, for the area of a triangle, we do 1/2 base times height. But to put all those triangles together, rather than finding each triangle individually, we know that those triangles come together to form the outside of the base. So how could we find, what's that called when we find the outside length of the base? Perimeter, yes. We're going to do 1/2 perimeter. Now instead of height, because height would mean from the top to the bottom and it would be that 90 degrees, we're going to find the height of a triangle, which actually ends up going up the side of this pyramid. So we call that, we use a cursive L, kind of loop-de-loop L. And we call that a slant height because it's going up the slant of the pyramid. Okay, so if we label that, capital B stands for our area of the base, and that's going to change based on what shape we're using. If we're using a square, it'd be length times width. If it's a triangle, we do 1/2 base times height. If it's a trapezoid, we do 1/2 of the height times base 1 plus base 2. If it's a hexagon, we do 1/2 apothem times perimeter, things like that. P stands for perimeter of the base. And then that L stands for our slant height. And slant height is the length up the side of the pyramid. Alright, that's where we're going to glue in our next shape, if you have enough space, glue that into your bottom part of your notebook there. If you don't have space, you'll just have to go to the next page, and that's okay. So once you have that all written in for your formula, and that's going to make this one go by a little bit quicker because we don't have to find the area of each side triangle. We can just, because we know all the side triangles are the same, we can just plug it into the formula. It makes our life a little bit easier. So go ahead and glue that next one in. About 45 more seconds to get that in. You guys are doing a good job passing around that glue. This chapter has a lot of glue ins because otherwise we'd have to draw these all by hand. And then I'd have to be an art teacher to tell you how to draw these all by hand. What? And which ones are dotted and which ones are not, and making an equilateral triangle first off on the bottom and then creating equilateral triangles on the sides. Oh boy. Alright, so here we go. First thing we're going to do is find the area of our base. In our formula, we need to find that capital B, which stands for area of our base. In our area of the base, what shape is my base shape in this one? That's a triangle. It's kind of goofy. There's a special place in my heart that pyramids go, and triangular pyramids don't go there, 'cause I hate them. They just look so goofy. So we're looking at this base here, and it's a triangle. So if I'm looking for an area of a triangle, what's my formula for area of a triangle? Half base times height. We've talked about it a lot today. So as I look at this triangle, my base and height have to make 90 degrees. So what two parts of this base triangle make 90 degrees? What two lengths? And it's kind of hard to tell because with that 90 degree, there's kind of two of them here. They're right next to each other. One is going this direction. It's going from that 10 up to the vertex. And then there's this one that's kind of laying down on that base. So for sure it's the 10 is our base. And then we have to do times our height. So should we use that 6.7, that side that's going from the 10 up to the vertex? Or should we use the 8.7, the one that's going across the base, to find our area of the base? You have two options. It's a 50-50. Take a guess. The 8.7? Sure, perfect. 8.7. Because that's going across our base. So when we find the area of the base, that's the one we'll want to use. Okay, again, use our handy-dandy calculators. 1/2 times our base, which is 10, times our height, which is 8.7. We get 43.5. All right, now for our formula, there's two more things. We could find the area of just the side triangle and then think about how many triangles there are and add them together like we did in the last one. But again, we can do it a little bit more simple by just finding perimeter and our slant height. So perimeter is of our base. So we're looking at around that triangle on the bottom. What are the sides of our triangle here? We have a 10. What else? 10 and this back side is, no, you had 10. Because remember, all the sides were equal. It was a regular polygon, so they should all be the same. 10, 10, and 10 makes 30. Okay, our last step of our formula up here is to find that L, that cursive L, which looks like a loop-de-loop. Okay, and the cursive L stands for our slant height, that height that goes up the side of the pyramid. So again, we want that 90-degree angle, but this time we want it to go up the side of the pyramid.
Why did you put that one on me? I'm sorry.
What's our length that goes up the side of the pyramid? Good, 6.7. So now it's just going to be about plugging it into our formula. So we have surface area equals, we're going to start with our capital B, our area of the base. What is our area of our base? $43.5 plus, and then it goes 1/2 times our perimeter times our slant height. And our perimeter is 30, good. Good, 6.7 for what? What do you call that, cursive L? So close. Slant height, there you go, slant height. Thank you for communicating, Michael, you're crushing it. Alright, and then we're just going to throw that in our calculator to get an answer. So 43.5 plus 1/2 times our perimeter, 30, times our slant height, 6.7. And we get a handy dandy 144. Ends up being a whole number, which is crazy. And because it's surface area, how should we label this one? Square what? Kilometers. Beautiful. Alright, on your practice today, your practice is going to start off by asking you if it's a regular pyramid or an irregular pyramid. So you're going to have to look at the base, identify what shape the base is, and decide if it's a regular or an irregular pyramid. Then there are 3 pyramids that you will find the surface area of.